Welcome back, everybody. Today, we are going to unveil the curtain and show you that, once again, you've been lied to forever. Okay, today we get to start 2.4. And there's one thing that your book does that I don't love, and we'll talk about it. It's nice to see. We will be talking today about the complex numbers. Now, quick check. I'm not just asking about the word complex, but who has heard in here or ever seen the complex numbers? Okay, that's about what I was expecting. Realistically, you have. You have seen them. You haven't seen all of them, but you have seen the complex numbers. Now, this gets used so frequently. Remind me, do we have shorthand for different types of numbers? Like if I want to write all real numbers, is there a symbol? R. It's the blackboard R. Do you remember what this one is? The integers, okay. Ooh, what's this one? Can you even tell me what letter that is? It looks like this if you can't see it. It's a blackboard Q. Rationals, nice. Ratios are fractions, and fractions mean division, and the answer to a division is a quotient. There's the Q, the justification for it. I don't have a good one for integers, just so you know. Okay, today we get a new one. Complex, we will represent in the future with a blackboard C. So it's this guy. It's just a C with a bar. These are the complex numbers. Now, not complex as in like super complicated. They're just very specific. And there's a little bit of motivation here. And we'll go ahead and just build that. I'm going to call it intuition. I want you guys to help me solve something really quickly. Okay, I'm going to give us an easy quadratic to solve. I want us to solve x squared plus 1, and I want to know when is this equal to 0. And we're going to do this just like we do every other factoring problem. We're going to run through our list. The very first thing that I always check is what? There is no GCF between 1x squared and 1. Bummer. Next thing I check is what? We made eye contact. We have a binomial on the board, I think, right? What am I hoping to see with said binomial? The difference of squares. So let's check. Do you know the square root of this?
Yes.
It's x. Do you know the square root of this?
Yes.
Why is this not awesome though? Is it a difference? No. So this is not a difference of squares. Now, if I wanted to expand out to grouping, I could. And it's weird to see, but do you agree that that expression right there, if we wanted to try to group it right now, it'd be weird to try to do it, but certainly could happen. Do you agree that this is the same thing? Like, that's just the same thing, right? And if we tried to group it, I need factors of positive 1 that add up to 0. So that's negative 1. Otherwise, I agree with it. So 1 minus 1 is 0. Let me rephrase that. They also have to multiply to be a positive 1. So the natural thought here is there's a way to get 1, but what does that add up to? 2, bummer. So, okay, we'll try this then. It must work with negative 1 and a negative 1. That's a product of 1, but its sum is? It's broken, right? So, with this, there's an issue. If we can't factor it, it's not the end of the world. If I do something to the left side of an equation, is that allowed as long as I do the same thing to the right? Always. With one exception, you can't do it if it's something that could be 0. So I would never divide both sides of an equation by x, because that very possibly could be 0. Like, I wouldn't just throw it in there. Now, if we can't solve this by factoring, do we know how to undo a square root? Dang it. Do we know how to undo a square? That happens at least twice a day, every day. So I could take the square root, but I want only x's, right? We want to isolate the variable. How do I move this to make it so it's only x squared on one side? Okay, so we can't factor. That's a bummer. But then we decided that x squared must be negative 1. And now I want to solve for x. I'll take the square root of the left, and I'll take the square root of the right. I'll do the left side. It's x. And you guys are going to tell me the square root of the right side. You might check a calculator, and I'll even hook you up. I'll try. Say that again? So if I try negative 1, what's negative 1 times negative 1? That was not the square root of negative 1, then. That was the square root of 1. Oh, my error? Huh. Now, here is the lie, and I'll even show you guys. imagine you believe it. But here's me trying to do it. Domain error. Can't do it. Okay, looking at this, our calculators don't do it because our calculators work with what are called the real numbers. Now, I hate the language. It is the worst choice that mathematicians ever just seemingly agreed upon, and I think every other math teacher ever, and even a lot of mathematicians, hate these numbers. They should have been called something else, but there's an issue here, right? Like, we don't know. This is our motivation for today. Now, we use language to represent stuff, and we just make stuff up. I'm just going to make a sad face. Nothing meaningful here. Okay. We use language to make sense of stuff. The real numbers. We just use that phrase, the real numbers. Give me some examples of real numbers. 1, 0, 2. We're not going to count to infinity. Give me a different type of number. You give me integers, which is good. They are. 0.2. I know where you have the rationals included. That's a fraction. 0.4. There's another rational. -1/2, -1/3. All of those things, right? Any goofy numbers that you never repeat or end? Pi. That is an irrational number. That's okay. It's also real. All of those are examples of the real numbers. Okay. Now, what's been working out there behind the scenes is you've actually been dealing with the complex numbers your whole life, but there's a very specific situation. This number does exist. There is a square root of -1. There is. Now, the language part. Real, when we say the real numbers, is there a physical object that's exactly 4 floating around in space somewhere? Like the quantity, the idea of 4 things, that exists with us, right? Like, because there's 4 things to count. But is there a physical 4 floating out there? Like, it's a construct in our minds, right? So this is the weird philosophy part of it. I'm trying to make it so that this word that we see, and Liam already knows it, but I don't want you to think of it that way. Does any number actually exist? Like, probably not. The idea of quantity exists, I think, but the number itself, like, if I ask somebody who's never heard English, does 4 exist? They're going to say, what the hell is 4, right? Like, they don't know what it is. They might use a different number. Okay, the word that we use. Now, with that then, are numbers real? No. I honestly don't know the answer, but I think that it's arguable. You could say, no, not really. They're numbers that we write are the construct that humans have come up with. Just like the word the, does that exist without human? The, or any word, ever. Do words exist without humans? Do they? Before the first human learned to speak, did words exist? But are words real? Maybe you want to say, yeah, there, and I'm okay. Like, I don't know the answer to that. But here's the issue. When we talk about these types of numbers, we're going to use a terrible choice of language. We are going to introduce imaginary numbers. Okay. The important part and why I'm making the weird philosophical discussion is because they are no more real or fake than what we call the real numbers. We just have these things that we call the imaginaries. Now, realistically, they should have been called something else. You don't need to write this down or nothing, but they should have been called these, the quaternions, because the math that worked out that made these things discovered came out of this idea. Okay. For all like real motivation stuff, if you are doing anything with electricity, which human beings use electricity pretty regularly, like we have, I wouldn't say we've mastered it yet, but we're getting closer to mastering it. We're getting better, more efficient ways of doing it. Nothing that you have in your life that runs through electricity would exist without the math and engineering that comes from the imaginary numbers. They are legitimately, in my opinion, more useful in a broad application than the quote-unquote real numbers. Okay. It's a language thing. Tomorrow at the start of class, we are going to see what this number is, how it works, and how we play with it. Cool.
Like that little, like, curved eye.
If you want a spoiler, I'll even give it to you right now. We'll do the same thing tomorrow. But it is exactly the number I. It is the number I. Just like pi is a number, or E is a number, it is a number I. We will pick up here tomorrow.